In this class, we're going to consider how you factorize an algebraic expression using completed square form. So this process is called completing the square, and generally we're applying this process to trinomials, but sometimes you'll see scenarios where it's a trinomial without a number on the end. So for example, maybe x squared plus 12x. So, well, I guess that's not really a trinomial. It's a trinomial though, I was going to say, in the sense that it's got a plus 0 on the end, and that's how we're going to think about it. So we'll work these three examples in a moment, and then we'll kind of look at this as sort of a special case. But basically what we're doing here, we're taking a general quadratic expression, so ax squared plus bx plus c, and we want to rewrite it in this completed square format. So the completed square format is when you've got x plus or minus some value p in a bracket with a squared on the bracket, and then plus or minus some value q outside the bracket. So an example would be something like x minus 2 squared plus 7. That would be in completed square format. If we expanded out that bracket, so if we went x minus 2, that's what it means to have a bracket squared, multiplied that out as two brackets, we would get x squared minus 2x plus 4, and then we've got that plus 7 on the end. Then just tidying up all the terms, x squared minus 4x plus 11. So now we've got a trinomial. So what we want to do in these questions is start with the trinomial and work our way to this completed square form. So we've got to figure out a process to get from here kind of backwards to here. Turns out the process is not particularly difficult. It's just a technique, a set of procedures, I guess, that you've got to learn. And the way that we do it is to focus on the fact that when you've got a bracket squared, that means the bracket times itself. But if it's a bracket times itself, then the two brackets obviously are the same. That means that if you get, say, a minus 2x, you're going to get a minus 2x twice. If this was a plus 3, you would have a plus 3x, but you're going to get that twice. So that middle term here is the combination of these two terms which are the same. That means that if we want to make a minus 4x, we know that in our bracket we've got to have half of that, because when we expand out the bracket we're going to get two of them. So that means that part of the process is always just to half that coefficient of the x. That coefficient just means the number in front of the x. So half the coefficient, keep the sign, so a minus 2 would stay as a minus 2, so you get x minus 2 squared. If we just stop at that point and think, right, if I did square that bracket out, what would I get? So that's x minus 2 times x minus 2. That would give me an x squared, a minus 2x, another minus 2x, and then a plus 4. Minus 2 times minus 2 is plus 4. Tidying up these middle terms, I then get x squared minus 4x plus 4. So that part, x squared minus 4x, that's what we've got here. The only thing that we don't have matching up is we've got a plus 4, we want a plus 5. That means we would need to add 1 on. So we need to add 1 here, we need to add 1 here, we need to add 1 here. That means we need to add 1 here. So when it comes to, in terms of it being a process to write these in completed square form, see if I can get rid of this. When we write them in completed square form, all that we do is take half the coefficient of the x, put it in the bracket. Then the only thing we need to consider is how to make the outside number. We just take this number and square it. Minus 2 squared is 4. We don't want 4, we want 5, so we need to add on 1. And that's all you really need to do. So to take that to this second example, and these are equal, by the way. Remember, this is just a rewriting of the original trinomial. So to take it to this example, we just set down our bracket and we put in half the coefficient of the x, so half of 10 is 5, put on the squared. We then just consider, okay, 5 squared is 25, so this squared out would give you a 25. We don't want 25, we want minus 7. So to get from 25, positive 25 to minus 7, we would need to take away 32. So if you expanded that out, you would get 25 minus 32, which gives you minus 7. So that's all you have to do. Pretty easy, right? This one over here, same thing. We've got a negative coefficient. Doesn't matter whether the coefficient's positive or negative. You just match it in the bracket. So x minus 3 all squared. Minus 3 squared is positive 9. We don't want positive 9, we want positive 2, so we would have to take away 7 to compensate for that positive 9. And then finally, having a look at this guy, slightly different format, like I said earlier, because the question wouldn't have a plus 0 on the end. This does tend to cause quite a bit of confusion, these questions, because the format doesn't quite tally up with a trinomial. But if we think of it as being a plus 0 in the end, that can be kind of useful. So we're just going to start in the same way. The process is really identical. We just go x plus half the coefficient of the x term, which is 12, so x plus 6 all squared. We square that out to get a 36. We don't want a 36, we want a 0. So that means that we've got to take away 36. Just in the same way that here we would get a 9. We don't want a 9, we want a 2, so we take away 7. Here we don't want a we don't want a 4, we want a 5, so we've got to add on 1. Here we just want to get a 0, so we've got to subtract 36. So that would be this trinomial written in completed square form. There's a whole bunch of reasons why we want to write trinomials in completed square form. We're not going to talk about those in this class. They're basically applications of this form. You get certain information from this form that you don't get from this form. Initially though, you just want to learn this as an algebraic process. Further down the line, you'll then reuse that process to actually achieve some things. But at the moment, just learn how to go through the procedure. It never really changes. It should only really be one line of work, and you can split it over multiple lines, kind of like I was thinking about over here, but that's kind of overkill. You want to get to the point where you can just go through the process that I went through, and then just one line of work in later, you've got the answer. So make sure that you recognize the format. It's very easy to forget this name, completing the square, completed square form, which is what these guys are now in. And it's just very easy to forget this technique. So practice enough of them so that it kind of goes into your brain. It's a kind of technique that's quite easily forgotten, but easily picked up again. So if you practice enough of them, even if you do forget it, you'll remember it again fairly quickly. So yeah, check out a medium number of practice questions on this topic.